Hi listeners, welcome to the video lecture series on power electronics. In the previous video, we have seen what is power electronics, goals of a power electronic systems, followed by advantages and disadvantages of power electronic systems. And in this video, we are going to see what is the power electronic converter and its types. Now let us go into the lecture. The specific outcome of this video is we are going to differentiate different types of power electronic converters used in power electronic systems and its applications. The reference book to be followed for this topic is Bimra PS Power Electronics, and the corresponding page numbers is also given here for further reading. Converter classification. We know that power electronic system acts as an interface between source and load. The main objective of this power electronic system is to match the voltage and current requirements of the load to those of source. So if the load is of DC in nature and if the source is of AC in nature, the power electronic circuit should properly convert the source to the load requirements. So power electronic circuits convert one type or level of a voltage or current waveform to another, and hence they are called as converters. So converters are nothing but power electronic circuit which is capable of converting one type of load, one type of level to another type. The power electronic converters are classified by the relationship between the input and output. Now let us assume that we have an AC source which may be fixed or variable in nature, and we have a DC load. The load may require a fixed voltage or a variable voltage. So I should have some sort of a power electronic converter between the source and the load, so that if the mismatch between the voltage and current requirements of the source and load can be easily addressed. So I require some sort of a power electronic converter between these two to act as an interface. And here, since the source is AC and load is DC, I require a rectifier which is capable of converting AC into DC and feed it to the load. Similarly, when we consider that we have a DC source and load is also of DC in nature, but source may be a fixed DC source like a battery or a variable DC source like a photovoltaic panel, and load may be a fixed load like an LED lamp or a variable load like a DC motor. So there is a mismatch between voltage and current requirements of the load to those of the source. So I need some sort of a power electronic interface between these two, and that interface is what we call it as a chopper. And again, if the source is DC and load requires an AC voltage or AC current, then I require interfacing component between these two, and that interfacing power electronics component is what we call it as an inverter. Similarly, I want to convert fixed or variable AC voltage into a variable or fixed AC voltage, then I require another type of power electronic converter which we call it as either as an AC voltage regulator or as a cycler converter. So here we have four different types of converters. One is AC to DC converters are called as rectifiers. DC to DC converters are called as choppers. DC to AC converters are called as inverters, and AC to AC converters are called as AC voltage regulators and cycler converters. So very importantly, you have to know that the DC to DC conversion is required when source is fixed, load requires variable one, or when the source is variable, load requires a fixed voltage or current. Similarly, in the case of AC also. So let us look into a simple example where these converters are employed. Now let us consider an example of a distributed energy generation system, something like this. Here I have a photovoltaic panel and a wind turbine. The output of the photovoltaic panel and the wind turbine is based on the environmental condition. If the environmental condition varies, the output of photovoltaic panel and wind turbine also varies. But here is a grid. Grid always requires a constant voltage and constant frequency. Then one important thing in the case of photovoltaic is power generated from the photovoltaic is DC, but whereas grid is of AC in nature. Power generated from the wind turbine is AC, but a variable AC, but grid requires a constant AC, constant voltage AC supply. So there is a lot of mismatch between the source and the grid. Here I require some sort of a power electronic converting equipment or a power electronic converting system to interface the source and the load so that this mismatch can be rectified easily. So this is what we call it as a converter system. So this type of converters are used not only in these applications. The power electronic converter has a wide spread of applications in many of the areas. Now let us look into the application of power electronic systems. Power electronics is a key technology for transmission, distribution, storage, renewable energy sources and user subsystems, and has spread in many applications across different domains. Here I have listed many domains where power electronics is a main application in it. So residential is one application. We are using refrigerators, freezers, space heating systems, air conditioning. All this requires some sort of a power electronic component into it. And similarly in commercial, similarly in industrial, industry is the place where we require a lot of power electronics application. Transportation is another sector where the power electronics is picking up in a bigger way. Utility systems also requires power electronics. Aerospace, communication. You can see there are many varieties of application across different domains in power electronics. That is why power electronics has become one of the important subjects in the electrical engineering is concerned. In this video, we have discussed different types of power converters used in power electronic systems. They are AC to DC converters, which we call it as a rectifiers, DC to DC converters, which we call it as a choppers, DC to AC converters, which we call it as an inverters, AC to AC converters, which we call it as AC voltage regulators or cycler converters. And we are seeing the applications of power electronic systems across different domains. This is what about this lecture is. And in the next lecture, we will see what is the meaning of an ideal switch and what is the meaning of an practical switch and the difference between these two. Thank you for your patient listening. Thank you.